So this unit is polynomials. And polynomials, we've actually already dealt with polynomials. Linear equations are polynomials. But since linear means you have variables raised to the first power, a linear polynomial has the highest exponent, the highest power is 1. Quadratics are polynomials, right? The highest power of x is 2. When you keep increasing the highest power of x, then you get a different polynomial. Like if we go one more, that's a cubic. If we go one more, x to the 4th makes quartic. X to the 5th makes quintic. Then after that, we usually just say 6th degree, 7th degree, like that. So in any case, we end up dealing with exponents a lot. So before we get into the rest of the chapter where we're actually dealing with polynomials, we have this is a review of Algebra 1 stuff, properties of exponents, just to refresh ourselves in all of this. And I would say overall, it's not a long lesson. It's almost 1 o'clock. By 1:30, we're probably done. And the homework is 12 problems. You'll probably not have any homework or anything. So I would guess that we'll have our quiz on the 24th and our test on the 28th. And right now, I think I've got the computer lab signed up for the 3rd to take a 9-week test. And that's like the end of the 9 weeks. Then we move on. So these are all the properties of exponents. And there's 7 of them. 7 of them. These are like the cryptic, kind of codes there, but if you would just look at the examples, it probably makes more sense to you. I gotta stay over here so the mic can hear me, but so when you multiply, like in the very first one, it says a to the m times a to the n, right? The a is called the base, right? The m and the n are exponents, and they could be different. That's why they use different letters for them. But how do you simplify that? If it's a multiplication, you add the exponents. In their example, 5 to the 3rd times 5 to the negative 1 is 5 to the 3 plus negative 1, which is 5 squared, which is 25. In all their examples, they're with numbers. So in the end, you can actually just find the answer. But we practice them with numbers because eventually we're going to do them with variables, and then you can't. Then you really do have to know the properties. So, I may ask you questions like, which property did we use? But ultimately, I don't really care about the name of the property. You just have to know how to use them, right? Now, if that's the one where you add the exponents, I kind of always think of it together with this one a little bit. What do you do when you divide a to the m by a to the n? You subtract. So one is a add, the other one is a subtract. Actually, sometimes I think of these two together, the first one and the second one. Because always the question, well, if you add with the first property, product of powers, when is it that you multiply? And you multiply when you raise a power to a power, what they call a power of a power. For example, here's their example, 3 to the 3rd in parentheses squared. That's the multiply. That's 3 to the 3 times 2, which is 3 to the 6th, 729. Okay, 2 of them that definitely go together are this one and this one. Right? What happens when you have parentheses, more than one thing inside parentheses, and it's got an exponent outside parentheses? How do you deal with the exponent? And usually what students will say is distribute. And it's kind of right? You're just going to take that exponent and move it inside on everything that's inside. Even if it's a divide situation, you know, make that m be the exponent of a and b. A to the m over b to the m. Right? What was I thinking there? Now, here's where you like try not to get confused. Like if you look at this power of a product, a, b to the m, when we distribute it, that's not the same thing as this, x plus 2 squared. Right? You can't distribute the squared because it's a sum inside. Right? It's in their example, this a, b in parentheses, that's a product. That's when you can move it inside. But don't confuse that with having a sum or a difference inside the parentheses. Then you can't. Right? And that leaves us with two properties. Okay, if you have a negative exponent, usually it'll say don't have any negative exponents in your answer, however they state that. So a to the negative m equals 1 over a to the m, meaning if you flip it to the other side of the fraction, then you get rid of the negative exponent. It becomes positive. Look at their example. 7 to the negative 2 equals 1 over 7 squared. Right? It's a positive 2 in the denominator because it was a negative 2 in the numerator. And then the last, the 0 exponent. A to the 0 equals 1 means anything to the 0 equals the number 1. Right? It doesn't mean that thing raised to the 1. It means the number 1 replaces it. And which kind of makes sense, because even if you look at the quotient of powers property, right, the subtract one, I mean, what if I have x squared over x squared? Well, by the quotient of powers, I should subtract, right? X to the 2 minus 2, which is x to the 0. But anything divided by itself is 1. That's why x to the 0 equals 1. With one exception, and it says right there, a does not equal 0. That would not be true if the a was 0. But we wouldn't be raising 0 to any powers anyways. But you look at the example they give for the 0 exponent, negative 89 to the 0. I mean, it's not so bad of a number, but the truth is that that's the kind of problem that they might have something kind of ridiculously complicated in there, and then raise the whole thing to the 0 power, and you just say, okay, the whole thing's 1. You know, we could say pi to the 0. What is pi to the 0? 1. You know, anything to the 0 is 1. So we're going to look through a few examples, do a few U-tries, and that'll be it. And these are already done. Right? And they are like stating the properties that they're using, and I've actually written the properties on the bottom just so you can refer to them right away. So notice the first step. Because you had parentheses and an exponent outside of parentheses, they distributed the 2. So negative 4 squared times 2 to the 5th squared. Right. Now the negative 4 squared, that you can calculate, right? That's 16. But 2 to the 5th squared, you need another property, right? How do you simplify raising a power to a power? Multiply. 5 times 2. So that's 2 to the 10th. And 2 to the 10th, you can use your calculator and get it. So don't forget, when there's numbers inside, you still need to raise them to the power. Okay. Now this one's an interesting one, because, you know, if you distribute the negative 1 to both 11 to the 5th and 11 to the 8th, you would get 11 to the negative 5 over 11 to the negative 8. And then, to get rid of the negative exponent, what would you do? You know, negatives mean you flip them, right? So the to the negative 5 becomes to the positive 5 in the denominator, and x to the negative 8 in the denominator becomes 11 to the 8th in the numerator. So actually, what you really do is you just flip the fraction. Notice what they did going from here to here. They just took what was inside and flipped it. And now it's all raised to the first power. And 11 to the 8th, to the 8th over 11 to the 5th, that'll be the subtract property. So 8 minus 5 is 3. I mean, you might have also done this. Why don't we just simplify what's in parentheses before we do anything? What's 11 to the 5th over 11 to the 8th? Subtract. 11 to the negative 3rd, right? And then I'll use to the negative 1. And then I use the power of a power, which means 11 to the 3rd. So there's usually like more than one way to simplify these things. You're not wrong whichever way you go. There's not just one right answer. So try this one. Which is the property? Power of a power. So when you raise a power to a power, you multiply 2 times 3, which is 4 to the 6th, which is 4,096. So power to a power. Okay, how about this one? Which is the property? Say again? Power of a product? I don't see that as a... Oh, power of a product? No. That would be when you have parentheses raised to an exponent. The product of powers, right? It's the first one. Okay, but what is the exponent on the first negative 8? There's a 1 there. You don't see it, but it's there. So this is negative 8 to the 1 plus 3, which is negative 8 to the 4th, which is 4,096. Okay, try that one. Which is the property? Power of a quotient, which just means distribute it, right? 2 to the 3rd divided by 9 to the 3rd, which is 8 over 729. Okay. Okay, so here we go. This is not a you try, but in the end we'll end up doing them all anyways. So any difference here? What's different about this that it had to be its own example? There's 3, and not just 2 factors. Nothing else I could see. So they just add them all up. -4 plus 6 plus 7, which is 9. And now it's a variable, so we're not going to simplify. That is the answer, b to the 9th. So definitely that was a product of powers. Okay, so you have parentheses, there's a quotient in there, and there's parentheses, and then there's an exponent. So using the power of a quotient, we distribute the -3 exponent to both the numerator and denominator. And then looks like we're raising powers to powers, so that's power of a power property twice. R to the -2 to the -3 is R to the -2 times -3, which is R to the 6th. And S to the 3rd to the -3 is S to the -9th. But then we don't want negative exponents, so we have to do one more thing to get rid of the -9 exponent. And what do? We flip it. Right? That's the negative exponent. So R to the 6th, S to the 9th. Okay, so there should be some U-tries in here. No, not yet. So simplify. Now notice that they got this. Well, first they have the 16 in the numerator and the 2 in the denominator. Right? Make sure that you don't get confused with the properties of exponents. And you're wondering, okay, now what do I do with the 16 and the 2? Those are numbers, right? 16 over 2 is 8. Don't subtract them, because I've seen that happen. And then the only other thing to simplify here is that you've got n to the -5th in the numerator and denominator. So they subtracted. -5 minus -5 is 0. And then because n to the 0 is 1, that one goes away. I mean, if I was simplifying this without even using properties of exponents, when you have common factors in the numerator and denominator, they cancel. Without actually having to use properties of exponents, you could have just canceled that. So the answer was 8m to the 4th. So try this one. So what'd you get on that one? So you just added them up, right? -6 plus 5 plus 3, which is x squared. Okay, how about that one? So first step, okay, got a 7. What's y squared times y to the negative 4? Right, add them up. What is z to the 5th times z to the negative 1? Z to the 4th. Okay, are we done? What do you have to do? Say again? Put what in the denominator? The what? Okay, so here's the thing, because I've heard some wrong answers here. The only thing that flips to the denominator is y, right? Not the 7. The 7 doesn't have the negative 2 exponent, so don't try to flip something unless it has the negative exponent. So you still have the 7 z to the 4th in the numerator, but in the denominator now you have y to the positive 2. That's a common mistake, is to flip more things than really get flipped. Okay, try that one. Okay. Is that good? Did anybody do it different? Yeah? What'd you do? Yeah, you could have moved the t up right away. Make it s to the 3rd, t to the 4th, and then do it. You know, in the end, it's the same thing. S to the 3rd squared, t to the 4th squared, which is the same thing. 2 more. So what should I do first? Distribute the 3? Okay. Anybody else? Anna?
I did x to the 4 minus x minus 3 for
Yeah, and I kind of like that better, just so you're not having to distribute that 3 to 4 different places. You know, just right away make it x to the 1st. If it's x to the 1st, then what is it going to be y to? Y to the 4th? I mean, so here's the thing. It's going to end up being y to the 8th in the denominator, like that. So usually, when you, like if you say y to the negative 2 over y to the 6th, you say, well, that's a subtract case. Let me do negative 2 minus 6. I get negative 8. And then you have to flip it to the bottom, right, because it's a negative exponent. Usually when you do these, since the higher power of y is in the denominator, you subtract from there. Just start out there, you know, don't make an extra step where you make it negative in the numerator and then have to make it positive in the denominator. Just say 6 minus negative 2 in the denominator is y to the 8th. You're going to get to the same place anyways. So it's up to you, but that's definitely the way I would look at that. And now we just have to distribute the 3 in 2 places, right? That'll be x to the 3rd divided by y to the 8th to the 3rd, which is x to the 3rd divided by y to the 24th. So if you distributed the 3 everywhere, you still should have gotten the same thing. And there's nothing wrong with doing it that way. It's not like a order of operations thing where it's like you always do in a certain order. You can do any order you want. It's very forgiving like that. And then the last slide is, last year we had the digital access to this textbook. So when I made my slides, there's always problems like this in the homework, and I would put them in. But then we lost access to the online book. So this is my last year's slides. So what did they do wrong in the first problem? Jason? Yeah, you're supposed to subtract exponents, not divide. Okay. Not divide. What did they do wrong in the second one? What does it look like they did? And they should have? Yeah, add, not multiply. And what did they do wrong in this one? Right. So if you're multiplying the base, the same base with different exponents, you simplify by keeping the same base and adding the exponents. You don't multiply the bases and add the exponents, right? So don't multiply bases. Okay, that's it. What did I say? We'd be done by 1:30 and it's 1:24.